If you want to be successful, influential, and sophisticated, change your daily routine, then you can change your whole life. I want to share a practical message with you that will advance your life, which I believe in record time. Here is my point this morning. The more you read, the more you learn. The more you learn, the more you earn. Got it? This is the most important formula to unlock your true potential. And here is the today's topic, which is on eigenvalues and eigenvectors. In today's video, I am going to explain the statement of Cayley-Hamilton theorem and the problem related to it. See, the problem here is verify Cayley-Hamilton theorem for the matrix A is equal to 1, 2, 3, 2, 4, 5 and 3, 5, 6. And also we have to find A inverse. See here, what is this Cayley's-Hamilton theorem? Cayley's-Hamilton theorem statement states that every square matrix satisfies its characteristic equation. What is this characteristic equation? See, let me explain you. The characteristic equation is modulus of A minus lambda I is equal to 0. So A is a given matrix. So here this is 1, 2, 3, 2, 4, 5 and 3, 5, 6 minus lambda times of I. I means the identity matrix. See here we have to multiply the diagonal elements with lambda and we have to subtract from this. So here from the diagonal matrix we have to subtract minus lambda. So here is the subtraction part and this is the characteristic equation if you solve this determinant. See here we are going to solve this determinant. The first thing here is this is 1 minus lambda. See here this is 1 minus lambda into, so we have to close this row as well as this column. So here we have to multiply these two. That is, this will be 4 minus lambda into this is 6 minus lambda minus 5 5 z. This is 25. So here from the middle part, remember, so we have to take one minus. So here is minus 2. And see, this will be minus 2 times of. So now we have to close this row as well as this column and next we have to multiply these two. This is 2 times of 6 minus lambda. So in the formula we have minus and this is 3 5 the value here is 15. Clear? And the next one here is 3. So 3 times of, so we have to use this 3 as positive, that is plus 3 times of. So we have to close this row as well as this column. Now we have to multiply, that is 2 5 is 10 minus, so this is 3 times of, this is 4 minus lambda. Clear? Now if I solve this, so I'll be getting a characteristic equation. So let me solve this one. So this will be 1 minus lambda times of, so if I multiply with 4, so this will be 24 minus 4 lambda. See here, if I multiply, this will be minus 6 lambda, minus into minus plus lambda square. This is minus 25. This will be minus 2 times of, this is 2 6 are 12. This is minus 2 lambda. This is minus 15 plus this value is 3 times of, this is 10. If I multiply, this is minus 12. This is minus into minus plus this value is 3 lambda is equal to 0. Clear? So here this will be 1 minus lambda times of. So here this will be lambda square. So this value is minus 4 minus 6. The value here is minus 10 lambda and this value is minus 1. And see, this is minus 2 times of. So here this is minus 3 minus 2 lambda plus this value is 3 times of. This will be 3 lambda. This value is minus 2 is equal to 0. Is equal to 0. So if I multiply with 1, see this will be lambda square minus 10 lambda minus 1. So if I multiply with minus lambda, this will be minus lambda cube. Minus into minus, this value is 10 lambda square. Minus into minus, this value is plus lambda. And this is minus into minus, this is plus 6. And this is minus into minus plus, this value is 4 lambda. So this value is 9 lambda. And this is 3 2s are 6 is equal to 0. So here, if you observe, so there is 1 lambda cube here. So this will be minus lambda cube. So this will be minus lambda cube. And see here, squares are, this is lambda square and this is 10 lambda square. So here, this value is plus 11 lambda square. And see, coming to lambda terms, the quotient of lambda terms, this is minus 10. This is plus 1, this is plus 4 and this is plus 9. So if you observe, this is minus 9 and plus 9 got cancelled and see what is left over, plus 4 lambda is left over. So this is minus 10 plus 1, minus 9 plus 9. So we can cancel these, and here 4 lambda is left over. And see here the constants here, the constants are, so here is minus 1 plus 6 and minus 6. So we can cancel this one. So cancel this. So we can cancel this plus 6 and minus 6, and what is left over? Minus 1 is left over. And let me show you. So the characteristic equation is lambda cube minus 11 lambda square minus 4 lambda plus 1 is equal to 0. So this is our characteristic equation. So the characteristic equation is this one, that is lambda cube minus lambda square minus 4 lambda plus 1 is equal to 0. See here, so this is so important. So here, according to the Cayley-Hamilton theorem, the characteristic equation is so important that the square matrix should satisfy this equation. So here, how this square matrix satisfies this characteristic equation. So what is the square matrix here? See, this is 1, 2, 3, 2, 4, 5 and 3, 5, 6. So here I'll observe that whether this A satisfies this one. So A cube minus 11A square minus 4A plus 1. I'll calculate this one and I'll see whether it is going to become 0 or not. If it's going to become 0, then square matrix satisfies its characteristic equation. See here, what is our A cube? So we don't know A cube and we don't know A square. So I'm going to calculate A square from this. So here A square value is also very easy. So A square will be A into A. So here A square is equal to, what is our A term here? This is 1, 2, 3. So here this is 1, 2, 3. This value is 2, 4, 5 and this value is 3, 5, 6. See here, for 2 times I'm going to write, this is 1, 2, 3. This is 2, 4, 5 and this value is 3, 5, 6. So if I want to multiply, see here, these are the sleeping lines and these are the standing lines. I'm going to multiply. See, let me show you the multiplication part. A square is equal to, so this is 1 into 1 is 1. So 2 2s are 4 and this one is 3 3s are 9. And the next one is 1 into 2 is 2. 2 4s are 8 and this value is 3 5s are, the value here is 15. So 3 1s are 3 and 3 2s 2 5s are 10 and 3 6 are 18. Clear? This one is 2 1s are 2 and next one is 2 4s are 8 and next one is 5 3s are 15. Clear? So 2 2s are 4, the value here is 4. 4 into 4 is 16 and 5 5s are, the value here is 25. So this value is a 6 plus this value is 20 plus and this value is 30. So 3 1s are 3, next one 5 2s are 10 and next one 6 3s are, the value here is 18. So this value is 6 plus 5 4s are 20 and this value is 30. And next one 3 3s are 9 plus, so this is 5 5s are 25 and next one is 36. Clear? And see here, the value will be A square value is very clear as this is 14, 10, 15. The value here is 25. So this value is 31 and this value is 10 plus 15, that is 25. So this is 20 plus 25, the value here is 45. So this value is clear as 56 and this value is very clear as 31 and this is 50 plus 6. This value is 56 and this is going to become 70. And this is going to become 70, 25, 25, 20. Yeah? So here we need the value of A cube as well. See here, A cube value will be, I'm showing, so A square into A. So here A cube value is, so here I'm going to write A square into A cube value. So what is our A square value? A square value is nothing but 14. This is 25. This is 31. So this value is 25. This value is 45. This value is 56. And this is 31. This value is 56. And this is a 70 into A. So what is our A value? So A is 1, 2, 3. So this is 1, 2, 3. This is 2, 4, 5. And this value is 3, 5, 6. Now I am going to multiply and I am going to show you the values of A cube as well as A square. So these are the sleeping lines and these are the standing lines, and see what happens here. So A cube value will be 14 ones are, the value here is 14. See, let me show you the 14 ones are 14. 14 ones are 14, 25 twos are, the value here is 50. And next one, 31 into 3, the value here is 93. And next one, 14 twos are 28 plus 25 fours are 100. And next one, 31 fives are 5 ones are 5. And this is 15, 155. 14 threes are, the value here is 42 plus 25 fives are, the value here is 125 plus 31, 6 ones are 6, 18, 186. So here the 186, 25 ones are 25, clear, and 45 twos are 90, and 56 into 3. So here this is 168, and 25 twos are, the value here is 50, and 45 fours are 90 plus 90, this is 180, and next one 56 into 5, the value here is 280, and 25 threes are, this is a 75, and next one 45 into 5 is 225, and next one 56 into 6, that is 336, 31 ones are 31, and 56 into 2, that is 112, and next one 70 into 3 is, this value is 210, the value here is 210, and 31 ones are, the value here is a 62, and next one 56 into 4, that is 224, plus 70 into 5, the value is 350, and 31 threes are 93, and 56 into 5, the value here is 280, and next one 70 into 6, so this is 7 to 7 and 6 of 420, the value here is 420. So if you add up all this, we'll be getting a cube value. So what will be our a cube? So a cube value is very clear, so use your calci if you find difficulty. And this one is 157, so this is 157, this is 283, this is 353, and the next one, if you add all these, this is going to become 283, and this is 510, and this is a 636, and if you add all these, the value here is 353 and 636, and this value is 793. So this is our a cube value. See here, so our a value is ready. What is our a value? So a value is nothing but, so a is equal to, this is 1 2 3, this is 2 4 5, and this is 3 5 6. And what is our a square value? So a square value is also ready. So this is 14, so this value is 14, this is 25, this is 31, so this value is 25, this value is 45, this value is a 56, clear, and this is 31, 56, and this value is a 70. So make sure that this is 56. And what is a cube? So a cube value is also ready as 157. So this value is 157 283, and next one is 353, and this is 283, and this is 510, and this value is 636, and this is 353, 636, and 793. So 93. Now we have to use this characteristic equation. So in this characteristic equation, if I substitute, so what is our characteristic equation? So which is nothing but a cube minus 11a squared minus 4a plus 1. So a cube value is ready as 157. So this value is 157. This is 283, 353. This is 283. This is 510 and 636, and 353 and 636 and 793, minus 11 times of a square. So what is our a square? This is 14, 25, 31. So this is 25, this is 45, this value is 56. So this is 31, this value is 56, is 70, minus 4 times of a. A is also ready as 1, 2, 3. So this is 1, 2, 3, this is 2, 4, 5, and this value is 3, 5, 6. plus I value is nothing but 1 0 0 0 1 0, and this is 0 0 1. So we have to find the equation here. So this is as usual, that is 157, this is 283, this is 353, and this is 283, this value is 510, this is 636, 353 and 636 and 793. So here minus, so we have to multiply with 11. See here, if I multiply with 11, see here, 11 into 14, the value here is 154. And next one, 11 into 25. 11 into 25, the value here is 275. And next one, 11 into 31, the value here is 341. Next one, 11 into 25, the value here is 275. And next one, 11 into 45, the value here is 495. And next one, 11 into 56, the value here is 616. And next one, 11 into 31, the value here is 341. And 11 into 56, the value here is 616. And next one, 11 into 70, so it is 770. Clear? And the next one here, if you observe, this is minus. So if you multiply with 4, so this is 4, 8, 12. This is 4 2s are 8, and this value is a 16. And 4 5s are, the value here is 20. So this is 12, this value is 20. And 4 6 are, the value here is 24. Plus the value here is 1 0 0 0 1 0. This is 0 0 1. Clear? And now, so we have to check whether this is going to become 0 or not. So here, this is 157 minus 154. This is minus 4 plus 1. So this is minus 4 plus 1. And next one, this one is 283. And the thing here is minus 275. And this is minus 8 plus 0. And the 353, this is minus, this is 341, this is minus 12 plus 0, plus 0 here. And the next one is 280, 283, and next minus 275, and next minus 8, and this is plus 0. And next one is 510, this value is 510, this is minus 495, and this is minus 16 plus 1. This is a 636 minus, this is a 616, and this is minus 20 plus 0. And this is 300, so this is 353, this is minus 341, and this is minus 12 plus 0. This is a 636 minus 616, and this is minus 20 plus 0. And this is 793 minus, this is 770, this is minus 24, this value is plus 1. This value is plus 1. So if you observe this one, so this is going to become 158 minus, this is again 158. So this is again 158. So if you see, this is 283 minus, this is 283. So here, this is 353 minus, if you add up this one, so this is 353. And if you see, so this is 283 minus, so if you add this one, so this is 283. So this is 511 minus, this is 511. So this is 336 minus, so this is again, sorry, 636 minus 636. So if you observe this one, 353 minus, this is 353. So this value is 636 minus, this is 636. So this value is 793 minus, this value is 793. This is plus 1 here. So here, observe that this value is plus 1. So this is going to be 793. So if you observe, so all the values got cancelled, or we got 0. So this value is 0 0 0 0 0 0 0 0 0. So here we got the characteristic equation. What is the characteristic equation here? So here this is a cube. See, let me show you a cube minus 11a square minus 4a plus 1. So a cube minus 11a square minus 4a plus 1, we got 0. So this is the characteristic equation in which the square matrix is satisfied. Therefore, every square matrix is satisfied. Therefore, every square matrix satisfies its characteristic equation. Hence, Cayley's Hamilton theorem is verified. And the next thing is we have to find out A inverse. So here is the characteristic equation. So here in which A is satisfied, that is A cube minus 11A square minus 4A plus 1 is equal to 0. So we got this equation. So we need A inverse. So for that I am going to multiply with A inverse on both sides. So A inverse on both sides. If I multiply, see what happens here. So this is a cube. So this value is a cube minus 11a square minus 4a plus 1, and this is 0. So both sides I have multiplied with a inverse. So if I send this a inverse inside, then a cube into a inverse, which is equal to a square. So this is 11 times of, if I multiply with a inverse, this is a, and this is minus 4 into a inverse into a, and if I multiply with 1, so this is a inverse is equal to 0. So this value is a square minus 11a minus 4 into I plus a inverse is equal to 0. So if you observe this one, so this is going to become a inverse. So for finding a inverse, so for finding a inverse, minus a square plus 11a plus this value is 4i. So all the values are ready here for this one. So a inverse is going to become, so a inverse is equal to minus a square. So what is our a square value? A square, it is very clear, as this value is 14, this value is 25, 31. So this is 25, 45, and this value is 56. So this is 35. So this value is 56 and 70. So this is minus times plus 11 times of a. So what is our a value? A is this one as 1, 2, 3. This is 2, 4, 5, and this is 3, 5 and 6, plus this value is 4 times of. So this is 4 times of I is nothing but 1, 0, 0, 0, 1, 0, and this is 0, 0, 1. And see a inverse value. So a inverse is going to become, so if this will be minus 14, this is minus 25, this is minus 31. So this is minus 25, minus 45, minus 56. This is minus 31, minus 56, and minus 70. Clear? And if I multiply with 11, so this will be 11, 22, 33. This is 22, this value is 44, this value is 55. So this is 33, this value is 55, and this value is 66. Plus if I multiply with 4, so this is going to become 400, 040, and this is 004. And see, our A inverse value is equal to minus 14 plus 11 plus 4. And clear? So this is minus 25 plus 22 plus 0. And this is minus 31 plus 33 plus 0. So this is minus 25 plus 22 plus 0. And this value is minus 45 plus 44 plus 4. And next one, this is minus 56 plus 55 plus 0, and this is minus 31 plus 33 plus 0, and this is minus 56 plus 55 plus 0, and this is minus 70 plus 66 plus 4. So here, so we need this one. Which value here we need? So this is going to become A inverse value. So A inverse is equal to, this is 15 minus 14, the value here is 1. So this is minus 3, and this value is going to become 2, and this is minus 3, and this is 48 minus 45, the value here is 3, and this is minus 1. So this value is plus 2, and this value is minus 1, and if you cancel this one, the value here is 0. So this is our A inverse value. This is how we have to calculate. So this is also so easy. So let me explain you for one time, as this is most important question. So we have to verify Cayley's Hamilton theorem. For that we need characteristic equation. This is A minus lambda I is equal to 0. So after solving, so after taking the determinant, so this will be the characteristic equation. So here we have to substitute substitute in place of lambda as a and c. So here we need a square value as well as a cube. For getting a square, the value here is this one, and for a cube, the value here is this one. So now I'm going to substitute a square as well as a in our equation, that is a cube minus 11a square minus 4a plus 1. So this is a cube value, this is a square value, this is a value, and this is I value. So after multiplying and solving, so this is our 0 value. So here a cube minus 11a square minus 4a plus 1 is equal to 0. Every square matrix is satisfied with the characteristic equation. Hence Cayley's Hamilton theorem is verified. So after that we need a square. So a inverse. So for that, on the both sides I multiplied with a inverse. So here I got a inverse. So I have sent these terms to other side, and therefore we have a square value, a value ready. And after substituting, so we got a inverse as this is 1 minus 3 2 minus 3 3 minus 1 and 2 minus 1 0. So this is how we have to solve. As the video is very lengthy, but the procedure and the process is so simple and so important, and definitely you can score more if you practice well. And if you really like, you know what to do, raise your thumb, pass it on to your friends, and subscribe to this channel, and stay connected for more interesting videos and more important videos. And your future is very, very important, and go to the playlist, and every video is ready for your preparation. Thank you so much.